which compresses the air and pushes all the molecules together. And then when you open it, it releases the pressure and the molecules expand, creating an insta-cloud. Pretty cool, huh? All you need for this is an empty water bottle. Then you twist the water bottle, which compresses the air and pushes all the molecules together. And then when you open it, it releases the pressure and the molecules expand, creating an insta-cloud. Pretty cool, huh? All you need for this is some empty cans, a bowl of ice water, and some tongs, and of course a stove, because that's where you're going to heat the cans. So what you do is you fill the cans up with just a little bit of water, and then you heat it on the stove, and then once it's hot enough, you can tip it over to put it in the ice water, and it will implode on itself. What you need for this is vinegar, a raw egg, and a cup. Then you just put the egg in the cup carefully and fill it with vinegar to cover the egg completely. And then you let it sit for 24 hours. And after the 24 hours has passed, you can take your egg out and you'll notice the shell will just kind of rub off. And what I did was I just went and ran it under some water. And there you have a bouncy egg. Now what it really is the membrane of the egg. You can also shine a light on it for some cool effects. And just to show you that it is a raw egg, and then there's the membrane. Okay, so what you'll need is some grape juice, baking soda, paper, we use cards, a bowl, and some Q-tips. And then I took a 1/3 cup of baking soda and a 1/3 cup of water and mixed that together. And then we drew our secret messages on our cards. And then you can have your friends paint with grape juice to reveal the secret message. This happens because the juice is acidic and the baking soda is a base. What you'll need to make this is a hot glue gun, a cap with a hole drilled in it, an old CD, and a balloon. So hot glue your cap with the hole drilled in it onto your CD, and then blow up your balloon, and I twist it so the air doesn't just immediately come out, and then put it on your hovercraft, and there you have it. The air greatly reduces the friction of the CD on the table, so you can make a really fun game out of it, kind of like air hockey. What you need for this is a PVC pipe, or a balloon will work just as well. And then you charge your pipe or balloon up by rubbing it in your hair or on your shirt, and then put it by the water. To make balloon racers, you need a straw, a balloon, and some ribbon. We use Christmas ribbon. And then you just feed your ribbon through the straw, blow up your balloon, and tape your balloon to the straw, and then tie off your string. We tied it to our door and then to the bottom of a chair. And then just blow it up and let go. Gallium looks like this when you purchase it, and then all you need to do is grab a bowl of hot water and put the gallium in it because it will melt faster. And then you can wear gloves if you want because it can get messy, but it's not necessary because it's completely non-toxic. Gallium is one of the coolest things ever, I think. It has a melting point of only 29 degrees Celsius or 85 degrees Fahrenheit, so it melts in your hand. And it's a metal. It's like a liquid metal. It's really, really interesting. And like I said, it is safe and non-toxic, although I would not let young children play with it unattended. Another really interesting thing is it expands as it cools, like water. And you can see here it formed crystals as it cooled. That's why you can't store it in glass jars. So this is really easy. All you need is baking soda and vinegar and a sandwich bag. And then you put the baking soda and vinegar together in the sandwich bag and wait for it to explode. We did this in our sink, and while it didn't make a huge mess, I wouldn't do this in my living room. So all you need for this is baking soda, vinegar, an empty bottle, and a balloon. And then get a helper to help you put some baking soda in your balloon. One person can kind of hold it open and the other person can spoon in some baking soda. Put some vinegar inside of your empty bottle. And stretch your balloon over top of the bottle. And when you're ready, you can dump the baking soda into the vinegar and it will create a chemical reaction which will fill up the balloon. You can also try it with a glove, which is really cool. One note about the glove: be prepared for a mess. It doesn't always come out the way it's supposed to. If you tried any of these experiments, I would love to hear about it. Let me know.
Okay, I hope you enjoyed that. You can see.
Yes, hello.
Yes, going on and off, on and off. You know, some of you will have network issues.
No, we didn't enjoy.
Yes, we didn't go off.
It was
Okay. Now, among all those experiments, the longest takes 24 hours. And most of them, I made sure I choose like most of them, I chose those that you can do at home. I know people have baking soda, people have vinegar at home, and the vinegar they've been using is, okay, they didn't specify, but it looks like that white vinegar, not this apple cider vinegar that people use for salad. But I think any can work. If it wouldn't work, they would have specified. So you guys can try out and then you send me videos. You can try out any easy one. You can try out the one for the egg. You can try out any of the ones of baking soda and vinegar. And then you send me a video. Is that okay? Are there any people that would like to try out but are not on WhatsApp?
I'll try out. I'll try.
Okay. And you're on WhatsApp?
Yes, I am.
Oh, so Martina is asking what's the video about. Okay, the video was mostly about the chemical reactions that happen around us. Like they happen normally around us, but we may not know right now that they are chemical reactions. Later on, like, okay, if things go well, like if the pandemic doesn't keep interrupting us, by like the end of S2, you should be knowing. You should be knowing why they are mixing the baking soda with vinegar. Why aren't they using water? Why aren't they using cooking oil? You know, why are they using that, and why does that happen? It's something to do with acid and alkaline things. So by the end of S2, you'll be able to know. But for now, I just want you people to be familiar with the chemical reactions that happen around you. You'll be very surprised. You'll be very surprised how many they are. There are so many. You're chemists, but you don't even know. Okay, so we are going to start the lesson. Let me get some chalk. Okay, so I'm back. What were we looking at last time? Who remembers?
We were looking at air.
Yes, we are looking at air. What did we discuss? We're not going to repeat what we discussed. I just want to know if people remember what did we discuss under air?
The components. We
Yeah.
discussed the components, the difference between carbon dioxide and carbon monoxide, then the properties of air, the physical and chemical.
Yeah.
The physical and chemical. Yeah, those are all.
Okay, so today we are going to first discuss these components. We discuss the uses because I know you know the uses. Then later we shall talk about how to separate them. Though I know some people already know these things because some people had already gone through this at school, but I just want us to go through it so that I'm sure we are at the same level. So when we looked at the components of air, I remember we had oxygen, so we can start with oxygen because apparently oxygen is the most important one. So what do you people know about oxygen? Oh, okay. So I have a student here, he's saying oxygen is used, okay, oxygen supports burning. That is true, oxygen does support burning. You tell me anything that you know about oxygen, okay? Yes, yes, Chigundu.
So oxygen occupies 21% of the atmosphere.
Okay, its percentage composition is 21%. Thank you. Yes, Gloria Chimera.
Oxygen supports human life.
Pardon?
Oxygen supports human life.
It supports human life. How? How does it support human life? Does it feed the people?
No, it's used for breathing, okay.
Okay, for breathing, or you can say for respiration. Because remember, I told you people in primary, when they ask you which air you breathe in, you say we breathe in oxygen. But in actual sense, you don't breathe in oxygen. You breathe in whatever is around you. So even if you have some carbon monoxide in the air around you, you breathe in that carbon monoxide. That's how carbon monoxide ends up poisoning people. If there is dust around you in the air, you breathe in that dust. When you breathe in air, you breathe in most of the components of air. You breathe in oxygen, you breathe in carbon dioxide, you breathe in nitrogen, you may even breathe in rare gases if there are rare gases around you. So we have to modify the answer and we say for respiration because when it comes to breathing, we actually breathe in most of the components of air. Okay. Yes, Alicia.
Oxygen is a byproduct of photosynthesis.
Okay, it's a byproduct of photosynthesis. Remember, photosynthesis uses carbon dioxide. So it's a byproduct of photosynthesis. Oxygen is like the most popular gas you people have looked at. So I expected everyone to have something to say. Yes, Gloria, your hand is still up. Are you giving another answer?
Yes, oxygen makes up water, some part of water.
Okay, oxygen makes up some part of water. Thank you. For those that don't understand what she means, let me just write part of the chemical composition of water. So later on, you will realize that most of the things around us are actually made up of either chemical elements or compounds. Now, water, we've been seeing water around us. We drink water, we bathe water, we use water to wash. We just know it as water, but there is actually a chemical background. You know that the chemical formula of water is H2O. At least that one you know from over cartoons or from where somehow most people know that water is H2O. Now this H2O, this H stands for hydrogen and this O stands for oxygen. So that's what she means by oxygen is part of the chemical composition of water. Any other contribution? Like I always tell people, if you feel like you do not want to use your microphone, you can always use the chat room. Florence said liquid oxygen is used as fuel in space rockets. Thank you. Yes, Marilyn.
Oxygen is a chemical element.
It's a chemical element. Okay, thank you. Yes, oxygen is an element, but then there are also oxygen atoms, there are also oxygen molecules. So I'm not going to write that one, not because it is wrong, but because you cannot specifically state it as a unique property or a unique characteristic of oxygen. Because we don't know what oxygen we are talking about, and we don't know whether we are talking about an atom or a molecule or what. We are just saying in general. So is this all you know about oxygen? Yes, Chibundo.
Oxygen has an atomic number of 8.
It has atomic number 8. You're going to lose people here. So for you had even gone as far as atomic numbers.
Yes, teacher.
Which school is this?
Kawente.
Hey. Okay. Okay, that's good. Yes, Elizabeth.
Oxygen has a boiling point of negative 183 degrees Celsius.
Okay, thank you. Yes, Rihanna.
Oxygen is used in welding.
Oxygen is used in welding. It's used with some other gas. It's used in welding. Let me just say it's in welding so that this will just look good. In welding. Then I remember someone said it's used as fuel in rocket. That is also true. Among the uses of oxygen, we have it is used as fuel. Then it's also, yes, Ruth Karunji.
It is used to, what? It's used for breathing. It's used to support patients who have difficulty in breathing.
For example, the people who are in hospital, those people those people that have COVID, they are on oxygen, so that oxygen is also used to support lives and save people. Atomic mass 16. Thank you, Florence. I see people are researching. That's good. Okay, I think that's all from the chat room. For those people that those people that are hearing these terms for the first time, don't worry about it. We shall look at it in future. Atomic mass 16. Of course, so with atomic, they're talking about the oxygen atom. That's why they're saying atomic. Yes, Chigundu.
Oxygen is colorless, odorless, and tasteless.
Okay, it is colorless, odorless, and tasteless. This one is a physical property because it's something you can tell by just looking, by just feeling, and using your tongue, or using any of your 5 senses. So that's why we call it a physical property: colorless, odorless, tasteless. Okay, I guess that is all from you guys. Let me check the chat room. Okay. Okay, so there is more about oxygen, but of course there are things that I didn't want to discuss today. For example, things like atomic number, atomic mass, things like the boiling point. Yes, but it's okay to have them here, to have an idea, so that next time when you look at them in details, it's not a new thing. Then there are other things you can talk about, oxygen, like the density, the melting point, and how it reacts with metals or non-metals. But we'll look at that in detail after we have covered all the other components. Is that okay? Okay, so for the sake of how we are going to conclude today's lesson, I want you to keep at the back of your mind the boiling point of oxygen. You realize that each of these components have a unique boiling point, and we use that to separate them later on. People will tell me what method we use to separate these components of air. So now we go to oxygen. Sorry, we go to carbon dioxide. What do we know about carbon dioxide? Of course, okay, when it comes to, you remember air is a mixture of gases. And when people are discussing mixtures and compounds, one of the properties of mixtures is the mixture itself has similar properties as its components. Or you can say the properties of the mixture are the average of the properties of the components, meaning that the things that make up the mixture have similar properties as the mixture itself. So when we say air is a mixture of gases, and these gases are gases like oxygen, carbon dioxide, rare gases, etc., etc., etc. If air is colorless, odorless, and tasteless, you'll find that all these other gases are also colorless, odorless, and tasteless. So that cuts across all the gases. Then, of course, there are those that are unique to each component. So those are the ones that we are concentrating on. And I want to see other hands. Achena and Apio, are you people twins? Or are you just sisters? Or even neighbors? Maybe your in-laws. They are twins. Huh? Yeah. One of you should present the set and you give me at least one thing you know about carbon dioxide. Even who? Azra used to participate, but these days, I don't know what happened. Okay, Melissa says carbon dioxide is used in photosynthesis. Husna says it's used in fire extinguishers. Yes, Agatha? Agatha, you give me your answer.
Madam, my answer has been said.
Okay, sorry about that. So why is carbon dioxide able to be used in fire extinguishers? Like, why don't we use any other gas? Why do we use carbon dioxide? Yes, now should I choose to give me the reason? Yes, Rihanna.
Yes, teacher, what's the question?
Okay, so I've got an answer here in the chat. They are saying because it does not support burning. Okay, that is correct. And I've got other answers. Let me see. It's used in preserving of drinks, like sodas, yes. Its percentage is 0.04. Actually, the one we use is 0.03, but like I said, the figures, like those figures are really just an estimate. We just use like a particular one to be uniform. Then atomic number is 6. Thank you, Karunji. Okay, you people already know about these gases, most of them. That's good. I think that is all. It is colorless. Yes, it is a byproduct of respiration. Okay. Let me see that people that have their hands up. Hopefully your answers haven't been mentioned yet. Yes, Mason.
Carbon dioxide is used to preserve tinned food.
It's used as a preservative. Yes, Regina.
Oxygen occupies, carbon dioxide occupies 0.03% in the atmosphere.
Okay, percentage composition. Yes, Chigundu.
Carbon dioxide has 1 carbon atom and 2 oxygen atoms.
Okay, it has 1 carbon atom and 2 oxygen atoms. Thank you. Then Florence says it is a weak acidic gas. Okay, thank you. These things of acidity and alkalinity, we shall look at them in details later, but it's good that you people have an idea about them. Then maybe to elaborate on Chigundu's answer, you remember carbon dioxide is CO2. So when he says it has 1 carbon atom and 2 oxygen atoms, he's talking about this. When you look at the C, C stands for carbon, so C is just 1. But when you look at the O's are 2, and O stands for oxygen. So that's what he means when he says it has 1 carbon atom and 2 oxygen atoms. I hope you people remember that carbon dioxide is CO2. Do you look at it in primary?
Yes, remember it's CO2.
Yes.
We learned.
We did.
Yes. But even those that had forgotten in the last lesson, when we were discussing carbon dioxide and carbon monoxide, I remember I wrote it down somewhere. Okay. Yes, Rihanna.
The boiling point of carbon dioxide is negative 78.46 degrees Celsius.
Okay, thank you. Yes, Elizabeth.
When air is being separated, carbon dioxide is among the first things to be removed.
Will be why? Why is it among the first?
Because at low temperatures, they can solidify and block the funnels.
Oh, okay, thank you. Because at low temperatures, it can solidify and block the tunnels or the tubes. Yes. Chigunda, are you giving a different answer or you forgot your hand up?
I'm giving another answer.
Okay, yes.
Carbon dioxide is a greenhouse gas. Carbon dioxide is a greenhouse gas. A greenhouse gas.
It's a greenhouse gas. Okay, thank you. Yes, Marilyn. Okay, I think after Marilyn's answer, we shall move on. because there are so many things you can say about carbon dioxide. Yes, Marilyn? I hope people understand what Chigundu means when he says it's a greenhouse gas. Usually greenhouses, they are just small, okay, they are houses, not like a normal house, but they are used to grow particular plants. They are very famous in those countries that that do not do much farming, but most times they use them for research. Like you put up a greenhouse just to research and find out how fast these plants grow, how fertilizers can help them. So the reason why carbon dioxide is a greenhouse gas is very obvious. It's because the plant needs that carbon dioxide. So usually in this greenhouse, people, it's like a man-made lake. You know how like man-made lakes, people dig the hole and put the water there?
Yes.
With greenhouses, they just, it's not even, actually it's like a tent. It's like a tent, but it's fully covered. Then they put plants in there. Most times they are these plants like vegetables, fruits, and then they want to find out maybe how long it takes to grow. Then they try to, it's basically for experimentation. They want to know if we use this fertilizer, will it grow faster than when we use the other fertilizer? Something like that. So that's what greenhouses do. They use them for many other experiments, also like to check like how weather is affecting the plants, things like that, basically. Okay, I'm seeing more hands up. Carbon dioxide has a triple point temperature of negative 56.6. Thank you, Judith. It is used to form rubber and plastics. Okay, thank you, Nuriat. That seems like a very simple answer, but it's actually a very good point. Later on, you'll see why. Okay, I think we can stop there for carbon dioxide. Okay, what I've seen so far is that people actually know a lot about these gases, but then also people know how to research, because I know some of this information you couldn't have got it off the back of your head. So it's good that people are using their internet. It is used to inflate life rafts and life jackets. Most time, the reason why, okay, someone may wonder why they use them there. Most times when they are inflating anything, it could be a balloon, it could be tires of a bicycle, it could be a life jacket. Most times when they're inflating, they don't sieve out. They don't say, let's only put oxygen or let's only put carbon dioxide. They just pump in air. So you will find that most of these gases can actually be put under there. You can say carbon dioxide is used in what? In life jackets, all those balloon boats. You'll find that you can put any of these gases under that, because when these people are inflating, they don't really isolate. They just want the thing to be filled with air. The difference comes in with those, what do they call them? They are like parachutes, but they are balloons. They don't really carry people. I think they call them air balloons. Air balloons. Yes, I think they call them air balloons. They don't really carry people like parachutes, but I think, what do people even use them for? They probably use them to just excite people. I don't think they have any use. They are air balloons. Thank you for confirming, Nuriat. Yes, so with those ones, they have to really use a light gas, because as something goes higher up there, it's something to do with gravity. You would have to be really light to keep rising up there. That's why even kites, after they go up to after some time, they come back. Even balloons, they reach a certain point, they come back. But those people usually want those air balloons to go a certain distance. So you have to specifically use a very, very light gas. That is when they isolate and they're like, let us use maybe helium, or let us use hydrogen. So there they can't just pump in air. Okay, so today I wanted us to mostly discuss how to separate these components. Let me get my book. Should we also discuss the rare gases? Rare gases are interesting.
Yes.
Thank you, Babire. I think we can discuss rare gases and nitrogen very, very fast. And then after we look at how to separate these gases, why it's possible to separate them, why are we even separating these gases? Are these people crazy? We are going to look at that. Nitrogen is used to make fertilizers, yes. Yes, Melissa, you can give me any. Or we can just finish the ones for nitrogen because they are really few, those ones.
Nitrogen is used in X-ray of electronics.
In X-rays, but it's not used alone. It's used with one of the rare gases. Okay, I think there is a question in the chat room. Let me first get these answers, then I come to it. Yes, Babire Shifra.
I have an answer. Nitrogen is used to fix nitrogen fixing bacteria into soil.
Thank you. That is correct. The reason why I'm not going to write that is because it's a natural process. It happens either by lightning or by those funny insects that be in the soil. It's a natural process. And nitrogen fixing bacteria. It's a natural process. I'm not going to write it, but not because it's not correct, but because, okay, when we mention like maybe uses of nitrogen, we want things that we can do, like things a man or plants can do to what? To use the oxygen or to use the nitrogen. But now, I don't know if people looked at the carbon cycle. I doubt. In primary, you don't look at the carbon cycle. I think the only cycle you look at is the water cycle. When you look at the carbon cycle or the nitrogen cycle, you realize that with the nitrogen cycle, the way the nitrogen is fixed into the soil is a natural process. It happens by light. It's caused by lightning. Whenever lightning happens, wherever it strikes, some nitrogen enters there. Let me read the ones in the chat. To store tissue samples. Yes, nitrogen has preservative properties. Do you know why nitrogen is used why it's used in like food packaging, or why it's used to store sample tissues? Because when you state these uses, you're supposed to know why it's able to do that. Okay, let me see. It has atomic number 7. Yes. Its percentage composition is 78. It is used in freezing food preservation. Yes. Okay, let me see these new messages. Boiling points. Okay. Nitrogen is used to make fertilizers. Liquid nitrogen is used as a refrigerant. Okay. What did I want to comment on? I wanted to comment on I've forgotten what I wanted to comment on. I hope it comes up a bit later. Slightly lighter than air. Okay. But you realize that most of the gases are actually slightly lighter than air. Later on, when we are looking at them in details, like we shall look at a chapter called oxygen, whereby we only look at oxygen. And then we look at a chapter nitrogen. So nitrogen is looked at mostly in S3, depending. Nitrogen helps in the X-ray stuff. Okay. These hands up, you have answers for nitrogen or for rare gases? Oh, I've remembered what I wanted
Madam,
to
for
comment.
nitrogen.
For nitrogen.
Madam, for nitrogen.
Okay, let me hear from Agatha first.
Nitrogen is preserved in bulbs to help them produce light.
To help them produce what?
Light, madam.
Produce what?
Light.
Light, like light.
Yes. Light, yes, this light in bulbs.
Okay. It's used
Teacher,
with one of the rear
isn't
gases.
that rear gas called?
No.
Yes,
Madam,
even me, I know the rear gas. But now the thing with
The rear gas.
okay.
no,
I
it's
think she was giving an answer
nitrogen.
for the rear gas. Okay, let me hear from who? Let me hear from Ruth Karunji.
Teacher, you were saying that it's used in tissue samples. I think it's because it has a very low temperature. That's why it's used to preserve.
Actually, you have reminded me of the thing I wanted to comment about. You remember I was telling you, you're supposed to know why these gases are able to be used wherever they are used. You're supposed to have a reason used to make fertilizers because plants need nitrogen. It is used in X-rays. The reason is, you look at it later in future, but it has something to do with the frequency, like the light frequency. You know, they use these X-rays to look inside, like to look deeper. Like normal light, when you use normal light in bulbs, you can see like on top of the chair, you can see your hand, like the normal hand. But when they're doing X-rays, they are going deeper. So there is a certain frequency they need. And you find that nitrogen has like a property to do with frequency that can be used in X-rays. Then things like food packaging, for some food packagings, like those that need to be cold, it's because of its melting point. Then for things like food packagings that may have like chemicals in them, it's something to do with nitrogen being inert. Nitrogen is an inert gas, meaning that, do you know what inert means? Does anyone know what inert means?
Is it connected to inertia or anything?
No. Okay, it might be, but not like directly. Okay, when you know that rear gases are also called inert gases, but inert is a word. Yes. Inert basically means non-reactive. If they ever tell you you're inert, it means even if they slap you, you won't react in any way. You'll just turn the other cheek, like Jesus said, and they slap the other cheek. If they say a teacher is inert, that means the teacher won't do anything. He'll just come and teach, even if you shout, even if you do anything. So inert gases are not reactive. They are not reactive. So nitrogen, like, is used to, it's even used in chemical reactions as an environment, because it won't react with things. It's inert. It's not very, very reactive. So that's also a property that you can use under food packaging. Then even tissue samples, you know, those tissue samples have to be preserved. The melting point is low, so they use nitrogen, because even refrigeration, it's the same reason, because its melting point is low. So it's used, it can keep things cold, it can keep things at a very low temperature. Tissue samples are things like, okay, in real life, there are things like liver, things like kidney, your heart. People have seen in movies, okay, those doctor movies, like when they are getting the transplant, it's usually it's either in ice or in something cold or a fridge. Yeah, those are tissue samples.
Yeah.
Yes. Yeah. Okay. Yes, Rihanna.
Teacher, I just wanted to say that nitrogen is used as an inert environment during experiments or reactions.
Okay, thank you. Yes, Chigundu.
Nitrogen comes from the Greek word nitron for native soda and gen for forming.
Okay, thank you. So someone is, I think she just wants to confirm. So they use nitrogen to keep our organ. Yeah, kinda. It's not entirely direct. They'll put the organs in nitrogen, but nitrogen is can be used in fridges. Those fridges that do deep freezing, they use nitrogen in them. So they will keep those tissues and those organs in the fridge. So nitrogen is used in the fridge. So they won't put the organs directly in nitrogen, but they put in a fridge whereby the nitrogen is used in the fridge. Here you will have many answers. Yes, Maysoon?
Nitrogen is used to preserve terms of some organisms.
Okay, thank you. Okay, let's move to rare gases.
Rare gases are used. Okay, rare gases like krypton and neon are used in light bulbs.
Okay, used in light bulbs. Thank you. Yes. Now who should I choose? Who hasn't given me an answer? Okay, Gloria Nachimera.
I'm going to say something about helium. Helium lights red when electricity passes through.
I have people heard, so that you echo for me. Used in light bulbs. Okay, I'm going to separate this a bit. The one used in light bulbs is argon. And then there is one used in those other there are different kinds.
Helium lights red when it's used when electricity passes through it.
Those are the ones I was going to talk about. They are those that produce colors. So you can say maybe used in advertising, because usually those that are used in colors are used in advertising. For example, you know those malls whereby during day the word is just ShopRite, and then when it becomes night, ShopRite is inside is red, then the outer part is white, or bars, like
even on billboards.
Yes, even on billboards.
Yes.
Yes. So that kind of advertising, they use rare gases, but of course you don't know that you use rare gases. For you just buy a bulb and you put there. Used in welding. Okay, thank you. They mix it with oxygen to do welding. Helium is used in diving tanks. Helium is used in diving tanks, and it's also used in air balloons because it's very, very light. It is the lightest gas. Okay, it's the lightest gas so far. You never know, this people may find some other gases. Yeah, it's used to inflate balloons. Thank you. It's used in welding. They use some of the rare gases, they mix them with oxygen and they use in welding. Thank you.
Excuse me, teacher.
Yes.
Excuse me, teacher.
Yes, Agatha.
Please, teacher. I'm requesting you to explain how rare gases is used in advertising. My network was off.
Your network was off. Okay. Some of these rare gases, for example, neon. Neon, when electricity goes through neon, the light neon produces is not white light. You people, I don't know if you learned about, did you do light? I don't know. Okay, if you didn't do it, you did light in primary. I think you do.
Yes.
Yes,
Yeah,
in primary.
Yes.
Yes, you kind of look at
and the parts of the light bulb.
Yeah, you kind of look at it, and most times you look at white light. Not so?
Yes.
But now, white light is the most common one, but there are also other kinds of light. Now, like red, blue, even bulbs. You can buy a blue bulb, you can buy a red bulb. The difference between those bulbs are the gases in there. Now, gases like neon at different frequencies of light, depending on like how much light is going through the gas, the color will change. So how is this used in advertising? They can use it they can put it on billboards, they can put it in front of malls. I used an example of ShopRite, but there are other examples. The bad thing, I don't overmove. But people watch movies, like when those people are entering the bar at night, you can see maybe like a woman. You may see a woman, but it's in form of light, a woman like on top of the bar. Yes. So, but then the woman may have like a red
small. They even sample small light bulbs on a string. Sometimes on some designs, like with different colors. They are very small light bulbs.
Yes, and they are different colors. They can even make the lady dress up in like a red skirt and maybe a black top, but it's light that is doing that. So they use rear gases in there. Then I think the most common one I can bring up is Christmas lights. I think they call them disco lights, but they are Christmas lights. The ones they wrap around the Christmas tree.
Oh yeah,
you find that,
Christmas lights.
Yeah, you find that the bulb, one bulb is red, the bulb is green,
golden.
Yeah. So I hope she has got it.
Blue.
Okay. Yes. Let me hear from Alicia. Then after I hear from Chipgondo. Yes, Alicia. Do I even pronounce your name right? Is it Alicia or Elisha?
Elisha.
Okay. Yes, Elisha.
Rare gases like the noble gas are used to form inert atmospheres.
Oh yeah. Because they are also very unreactive. They can form in inert atmospheres, but rare gases can also be called inert gases and can also be called noble gases. So like noble is not an example of a rare gas, it's just another name for rare gases. So you can call them rare gases or inert gases or noble gases. Actually, when later on in future, you will even forget that they are called rare gases. You'll be calling them inert gases or noble gases. Let me hear from Chief Gundu. Let me hear from Chief Gundu. Is rushing. Okay, I think maybe he has got some issues. Yes, Mason.
Rare gases make up 0.97% of the air.
Okay, thank you. So Nuriat is asking me what are diving tanks. Diving tanks are, you know, those you people who dive, like who go deep down into water. They usually go down with tanks. Those tanks are supposed to make them lighter because if you're not light enough, you will sink in the water and you will drown. So they usually, apart from oxygen, they usually have some balloon-like thingies to help them float in case they need to float. But specifically, diving tanks are filled with helium because helium is super light. Have you got it, Nuriat? Those things they go with down when they are going down to dive. Those white people when they are going
Yes.
Okay, Chigundu, you're back. Yes, you can give me your answer. Let me remove this and we just
Teacher, excuse me, teacher, I have 3 answers.
Okay.
Number 1 is rare gases are monatomic gases.
Mm-hmm. Okay.
Then second, they have high ionization energy.
Okay.
Then I just wanted to add on what you said about the advertisement, those stuff. Those advertisements are called neon signs, whereby
Okay.
the neon, yes.
They just keep using different frequencies to produce different colors. So some monoatomic means one. Whenever you see mono means one. So monoatomic means one atom. And I'm not going to write that one down because it's above what? Above S1 level. Thank you, Chief Gundu. Thank you for doing research. For those that have not understood, it is okay. You look at them in details a bit later. I don't know if you watch Young Sheldon. I think Chief Gundu is our Young Sheldon here. Because the information he has.
Yeah, I do.
That cowboy.
You must have got it from Google.
Yeah.
I
I'm not
don't
that
think
cheap
it's
to
from
get
his
things from
head.
that.
I don't think it's.
No,
I don't
When
think
I went
it's
to
from
Google
his
to
head.
check, I found
Madam,
those
that is
answers
no,
there.
we
I'm
had
pretty sure he
studied this
got it
stuff
from
at
Google.
school.
that is
We had
Google.
studied this
Oh,
stuff
when
from
Teacher, that is
school.
Google.
It's from his
Okay,
book.
okay,
Not
calm
Google.
down.
We
It's
had
okay.
studied this stuff from school.
Google.
From your book.
From
Google.
school.
People
Your
stop
book.
hating.
Rush
It's
hour
okay.
schools, we had started
From
learning.
your book.
Enda
Your
kucharging,
book.
listen. No,
It's
sigenda
okay.
kulala.
It's okay.
Madam, that's Google.
Okay.
Or just reading from the book.
What am I told?
Yes,
okay,
because
it's
we had
okay.
lunch
from
already
the
this
book, not
start,
from your
so
head.
He's reading from the elders' book, madam. He's lying. Elders' book.
It's
Wama.
okay. You
no,
people stop
I can
hating.
even put my video
Tell
right
him.
now.
Yes, Wama. If you studied, don't hate you people. Because you didn't study the things. And if he's using Google, you also use Google and you give these answers. Because if the people that are here
Yes,
have
tell them,
internet,
let
that
them
means
use
they
Google.
can go. Yes, they can go to Google and you Google. Yes. Okay. That is certain. So if for the thing that I wanted us to discuss today, and we can call it a day, is the separation. So at the beginning of that video we watched, you realize that the man or woman, we didn't really see, but they just showed us hands. The person got a normal bottle, a water bottle, and then covered it, and then started squeezing. And then you realize that after he squeezed the lower part and opened the upper part, whatever came out looked like smoke, kinda. Yet the bottle did not have smoke. Did people realize that? For those that were here.
Yes, teacher.
Oh, okay. By the way, I've just remembered there is a question I did not answer. I think Isabella had asked something, but I didn't answer. Maybe I'll go through the chats again and answer. Neon signs are those things we've been talking about, the ones that are colored, the colored lights. The woman, the word ShopRite, the word Garden City, the word what? Which other thing
Even
is
the word
painted?
bar.
By the way,
They put it,
the
they
word
get
bar.
the lights and put it, yeah.
Yes, those
Even
are
on the
the
petrol
ones.
station.
Yeah, one might remember, even petrol station, Shell, Total, those ones. Those are what we call neon lights, those colored lights. I hope I've clarified
Even those beer bottles.
Yes.
Okay.
Even those
You
beer
people have
bottles on
distracted
the
me.
inside.
Okay, I was talking about separation. Now that we have this, you people have realized that these gases, like when you use them alone, they actually have more uses than when you use the whole mixture. Because the whole mixture is air, you can use it. Okay, we breathe it in. Plants use some of it. They use it to inflate tires, but you cannot use the whole of air to make fertilizers. You cannot use the whole of air to make things like neon lights. So that answers why we separate these components. Because someone may ask me, but teacher, why are we even separating these things? God created us with our air. Air is there free. Why are people struggling? They are buying expensive equipment to separate these things. It's because once you separate them and you have each component, they are more uses if you separate that component. So the separation I'm going to look at today is very, very simplified. Very, very simplified. But later on, when we look at oxygen, when we look at the industrial prep of any of these things, we shall go into more details. But for now, we are going to, you people are discussing in the chat room, you pay attention. Is the blackboard blurry for everyone?
No.
No, it's clear.
No, madam.
Quite clear.
Excuse, madam. Me on my
Very
screen, I'm
clear.
not seeing clearly. I have to first come very near.
For me, it's very clear. I can even read from.
It's not
Okay,
clear.
sometimes it's a network issue. Sometimes it's a network issue, sometimes it's the phone. But like I told you guys, you can always go and rewatch these recorded videos. So when we are looking at, I've told you about, we discussed that experiment, and we realized that what came out looked kind of like smoke, yet whatever was inside was nothing. And then later, earlier when we were discussing air, we said air can be compressed. Air can be compressed. Now, when these chemists or when these scientists, when they want to separate these components, they first compress the air. Why? When you people studied separation of mixtures, I know people studied mixtures, not so? And you look at separation of mixtures, manure filtration, what? Did you look at gas-to-gas mixtures? Because remember, we have liquid, we have liquid-solid, and then we have solid-solid. And you remember, we didn't really look at like gas-to-gas mixtures, like gaseous mixtures.
Teacher talked about it a bit.
Yes, we talked about it. Talked about it a bit, but okay, did she give a particular way of separating gaseous mixtures?
What I can try to remember is that we had to compress the air into liquid form, and then we would separate it from that point with the best or most suitable method.
Okay. Rihanna, did you have the same thing to say? Yes, Rihanna.
What I remember is that our teacher told us to search about fractional distillation of liquid air, which is the way of separating components of air.
So if we realize there is no way of separating the gases themselves, so we have to compress the air and make it liquid. Does someone know how compressing the air makes it liquid? And you explain to us. Because you've compressed the air, but how does it become liquid? Do you people have any idea? Do you have your own theory of teacher? Me, I think this is what happens. Yes, Ruth Karunji.
I think when you keep compressing the gas, the molecules keep coming closer together until they become a liquid.
Okay. Hey, Martha, did you have the same answer?
Yes.
Okay. Rihanna.
I think that when you compress the gases at low temperatures, they change, they can become liquids.
Okay, so you studied when you were studying matter, you looked at the states of matter, solid, gases, liquids. You realize that in solid, particles are very, very packed. They are so packed. They even have no place to breathe. They are so packed. I hope I've packed them enough. Then you realize that in liquids, they are spaced, but not so much. Okay, they are not very packed, but they are also not very spaced. They are just in the middle there. Then you find that in gases, they are too spaced. They are very sparsely spaced. Yes, Marilyn, your hand is up. Okay, I get.
When we compress that, it turns pale blue.
Oh, okay. I thought you had something to say about this. Anyway, so we are here. Air has gases in it, so it's in gaseous form. So as you're compressing it, as you're applying the pressure, these particles are coming closer and closer. It's what happens even in a room. If you keep pushing, let's say a room has 50 people and you keep pushing them together, they come closer to each other and come closer to each other. So you find that as you're compressing the air, these molecules, they are coming closer to each other. They keep getting closer. Then at a certain point, these molecules will be close to each other as molecules are close to each other in liquids. You know that in liquids, they are close, but not very close. So as you compress the air, these particles come close to each other, and at some point, they'll be close to each other the same way molecules in liquids are close to each other. And then that air will become a liquid. And that is what we call liquid air. Yes, Chigun, do you have a contribution or a question?
Yes, I want to talk about air compression. Like compressing the air makes the molecules move more rapidly, which increases the temperature of the air.
Okay. Okay, thank you. Because there will be more collision. There will be more collision. Remember, when you look at the kinetic theory of matter, particles are always moving. Now, if they have less space, let's say there were many particles like in this big space. So you find that one can collide with the other, then they separate. Then by the time they meet each other again, the day has ended. But now when you reduce the space, you find that they keep knocking each other. They go this side, they knock each other. So there is more collision. And wherever there is more collision, there is more heat produced. So what Chibudu is saying is actually true. Thank you. Have people understood this? Have people understood how compressing air can turn the air to liquid?
Yes.
Yes, teacher, we have.
It's just the molecules. Once they compress them, they come close to each other, and at some point they'll be close to each other the same way they are. Okay. So after you have got your liquid air, I said I'm going to give you the simplified version. After you've compressed the air and you have this liquid air, you use fractional distillation. I think someone already mentioned that. We use fractional distillation to separate these components of air. So I'm going to ask a question after Chibudu tells me what he has to say. Yes? Maybe you forgot your hand up. Okay, let me ask my question. Why are we able to use fractional distillation to separate this liquid air? It's supposed to be like a paragraph. That's I'm answering Nuriat. It's supposed to be like a paragraph. It's not, you can write it as 2 or 1 as one paragraph. Okay, why are we able to separate these things using? Yes, Henry.
I think because they have different boiling points.
Yes, because they have different boiling points. So this is because we have different boiling Okay, for those who are not sure how to raise their hands, like how to raise the same way the others, because if you use the video, oh, okay, by the way, when you put your video, I can easily see you the way Henry did it. So if you do not want to do that, what you do, there is something down here. Auntie me, I entered as a teacher, so I don't have it. But I think below participants, right? Below participants, you tap something. Can someone help me help the others?
Yes. For some people, when you go to participants and you click on your name, because it's the first one there will be more, and with more, it should show you raise your hand. Or if then for another group of people, when you go to your reactions, there's also raise your hand there.
Okay. Okay. I hope people have got it. She has said under participants, there is more. So you tap on that more. And
No, you go to your name, then you tap.
You go to your name, then you tap on more.
On some, not all, on some.
On your name?
Yes, then you tap more. There will be rename and some other opinions. Sometimes they can be raise your hand. Then on others, there is reactions where you tap and you go raise your hand. You just click on raise your hand.
Okay. Because now the video thing may not work for example, now in math, when you start bearing, sometimes I'll ask people to turn on your videos and you show me your work. So if like many people's videos are on, you may raise your hand and like I do not see the video. So that's why I wanted us to go through that one, because if you raise your hand, it's very easy. It's very easy to see. Okay, so I should have even stopped the lesson at like 10, but we've used more 19 minutes, but it's okay, we are still within that time. So that is the simplified one, but there is also another one that I'll go through with you later on when I see if it's necessary. I'll go through it with you. So I'm going to I want to show you something. I want to show you a table. I hope people ate because we've used more than 1 hour.
Teacher, even I'm yawning. I did not eat.
Okay, I'm going to just show you this, then we call it a day.
Excuse me.
Yes, please.
Can you please move aside?
So that you can see the board?
Yes.
Okay. Have I moved aside?
Yes.
Thank you, teacher.
You're welcome. I'll be giving notes, just that I know people covered the A. I don't want people to have repeated notes. I'll be giving notes when we do the other things. In case people are wondering whether we shall just be revising things as if we are doing a discussion, no? I'll be giving some notes. By the way, among the things you're supposed to be using, the internet is among, so Googling is totally okay. in case you weren't sure, you can always Google, do research. If you don't believe something, you discuss it with your friend or with a teacher. I should have organized this before the lesson. I know people are tired, so after we look at this table, we shall call it a day. Actually, we shall call it a week because this is the last lesson of the week. It's not there, you people. The thing I wanted to show you. Okay, that's okay. Okay, I don't know if you can properly see. Let me try to put it close to the camera. No, it is not clear.
Teacher, I can share the screen. I have that work.
Okay, you share with us and you show them that page so that you can see that the boiling points, and then
Teacher, the host has disabled screen sharing.
it's okay. Okay, so next time we shall start from that page.
Sorry,
basically.
teacher.
Discuss more. Okay.